All right. This is 11.3 normal distribution, and this is the notes that go on worksheet 11 and 12. Okay. I'm taping so that third and fifth period have to watch it tomorrow because they had their work day today because everyone's gone for chem. Okay. So tomorrow you guys get to have a work day. All right. I will not be here. Well, I'll probably actually be back partway into the class, but all right. This is the last new topic in stats, and then we're going to review Wednesday, take the quiz Thursday. Yeah, because we just don't have any time left. I backwards planned, and I cut stats as much as I had to. I wanted to have at least 3 days for limits at the end, okay? So we have 3 more days of new stuff on limits, and then the rest of the time we'll be reviewing. Because there's a whole bunch of days when big blocks of you are gone again for other tests. All right, here we go. Probability distribution can be reflected when it's symmetric with a continuous probability distribution, okay? It's called the normal distribution, and the characteristics are as follows. The graph is bell-shaped and symmetric with the mean being right down the middle. The mode, or the highest point, is also right there in the middle. And the median is in the middle, meaning half is above and half is below. Now, this isn't always true for data, and so sometimes we force data to be more normally curved than it should be. And then there's sometimes where this isn't a good way to do it at all. But the questions that you will use this for on my quiz and my worksheet will all say the data is normally distributed. That's your hint that you're using this, okay? The curve is continuous. It approaches but never touches the x-axis out on the far left and the far right. And the total area underneath the curve is 100%, okay? This is an example. The distribution times of a 400-meter run in a random sample of 100 athletes. By increasing sample size and decreasing the width in each little piece, they cut the little histogram down into smaller and smaller chunks and made it approximate the normal curve. Okay? This is the equation. If we wanted to actually graph it by going into y equals, is that looking fun to you? Okay. And you can't graph it unless you put in a number for the mean and a number for the standard deviation, and it's still a nightmare. Back here you have e to the negative, blah, 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 okay? We're not going to do that. We're just going to talk about what happens to the curve, and then we're going to use the mean and standard deviation to sketch these. For every normally distributed random variable, the shape is dependent on the mean and standard deviation. So this graph right here, if the red one would have a smaller mean and a larger standard deviation, meaning it's more spread out. Okay, the bigger the standard deviation, that's how far the data is spread away from the mean. The blue one would have a smaller standard deviation and a larger mean. It's all smushed together. This one is just a shift because the mean here is a smaller, the standard deviations are equal because they're the same width, but one has a lower mean than this one, okay? So this could be, you know, the SAT scores from one year and the next class was really smart and the SAT scores from this year, okay? All right, the empirical rule is this idea that we're gonna break this down and say, if it is a perfect normal curve, 68% of the data will fall within one standard deviation of the mean. This is on your reference sheet. It's the green one, right? Okay. We're also going to use the calculator to determine this, but roughly 68% will always fall within one standard deviation. 95% is within 2 standard deviations. So 95% is going from the mean minus 2 standard deviations down here to the mean plus 2 standard deviations up here. That's 95%. Okay. If you go out 3 standard deviations, it says that's 99.7%. Even in AP Stats, I believe they use 4 as the limit. 4 standard deviations is about as far as you ever go out. Okay. 99.7 is within 3. Do you understand? So even if we went out 4, there's like nothing out there. Now, we do have to be a little bit careful because if we want to talk about this half, well, half of 99.7 is a good estimate. From here on down is actually totaling 50%. Does that make sense, guys? Because this is the median. All right. So this question says the heights of 880 students are normally distributed with a mean of 67. So you would put 67 right down the middle. And a standard deviation of 2.5. So you would go up by 2.5 and down by 2.5. So 67 minus 2 is 65, minus another half would be 64.5. They went up by 2.5 this way. Now it says, how many students are more than 72 inches tall? Well, when they added 2.5 and 2.5, that was 5 inches, so that we're up to this percentile, which here shows that this is 34, this is 13.5, okay? So this is 34, this whole half is 50%, and this was 13.5. So what is above there would be the rest. How much of the percent is that? Take off the 50, the 34, the 13.5. That's going to be the 2.5, is that right? That's where they got that number. Left up above there is 2.5%. Now, they want to know actually how many students that is. Well, if we say 2.5%, that's 0.025, right? Of how many students were we talking about here? So they multiplied by 880 and got about 22. Does that work out? Did someone type it? 0.025 times 880? I think you have to round to the nearest whole number. It does? Okay, I'm just kidding. All right, second part of this question says what percent? When they ask a percent, we don't have to do that last step. All we have to figure out is the percentage that fall between here and here. Now, if the mean was 67 and they want us to find between 59.5 and 69.5, well, if you go 2.5 this way, you're up to the 69.5. If you subtract 2.5, we were at 64.5, take away another 2.5, we are at 62, take another 2.5, and we're at 59.5. All right, this is 68% of the data. This is 13.5, this is 2.35. If we add all that up, it comes out here. There's a way to do this on the calculator, okay, where we put the lower limit and the upper limit, and it just gives us the percent. It's a beautiful thing, okay? It's going to be the normal CDF because we're going to combine the probabilities from one limit to the other. So on your calculator, it's second VARS, and it's the second one down. Everybody find it? Now, you can put z-scores in here, and I'm going to talk about z-scores in just a second. But does this one already give us a lower and upper limit in the question? It says between 59.5 and 69.5, right? So type that as your lower limit, 59.5 and 69.5. And then it asked for the mean, which they told us was it 67, guys? And the standard deviation was 2.5, right? And then you can just hit enter. And it will tell you 83.99. Now that's not what we got when we added it up here. It's slightly different. Okay, the calculator is programmed to be more accurate. On here, you would be typing the lower limit, the upper limit, the mean, and the standard deviation. Okay? Everybody all right? You have an older calculator, it's lower, comma, upper, comma, mean, comma, standard deviation. And that's what you're typing in. Yes. Because the calculator is not using this empirical rule, which is kind of like just an easy way to estimate. Okay? All right, we're going back. You have this question, yes? Okay, let's do it by hand first. Okay, can we do one by hand? Whoa, that's a horrible sketch, but we're going to go with it. Okay, the standard deviation, or the mean goes in the middle and you write 65. Then what am I supposed to count by going up and down? It says go out, and this is 5, go out the same distance again. Oops, I'm sorry, go down 5. So this would be 60, sorry. Go down 5 more, you'd have 55. Go down 1 more and you'd be at 50. If I go 3 standard deviations this way, I'd have 70, 75, 80. Did I do that right? Okay. So we want to know what falls between 50 and 70. According to the empirical, this is how much? It says 2.35, 13.5, 34, and 34, right? 2.35, 13.5, 34, and 34. Is that what it said, guys? So if we add all that up, what do we get? 0.8. Okay, 83.85. Okay, yes. Now, if we do it on the calculator, if you use number 2 here, it's between 50 and 70 when there was a mean of 65 and a standard deviation of 5. Okay. So it says 83.99, so we're still getting roughly 84%, which is what the choice would be. Most of these are multiple choice questions on the quiz, and it'll just say 84%. Okay. All right, so let's try this one. I'm going to try by hand again first. The heights of 200 trees are normally distributed with a mean of 120. What am I going to count by going up? 16. So 136, 142, 152. How am I doing? 168. Is that right? Okay, going down would be 104. Help. 88 and we're subtracting. Okay, 72. How many trees are more than 136? Okay. We've been practicing for quite a while. We just did 2 questions where all of this totaled how much? 84, right? So this question asks how much is above that. So we would say what? Yeah, 16%. Okay, so 0.16 times, this does ask exactly how many trees. So like Jared said, we need to multiply by 16% times 200 is 32 trees. Nicely done. All right. If we use the calculator, I'm going to just use for this question real quick. If it says no upper limit, guys, if you have no upper limit, it says everything above. What did it say? Everything above 136. Okay. You can find a fancy way to do this. You can also just put a bunch of 9s in there. Yep. All the way up. Okay. And then the mean was what? 120 and 16. Okay. So we'd get a decimal, which is almost that. And then if we multiplied by, what did we have? 220 trees or 200 trees? Okay. So I got 31.7. Is that still going to round to 32 trees? Okay. What percent between 88 and 104? Again, you could use the calculator, but if we use the empirical rule, this is 68%. This adds another 13.5. And, oh, that's all it asks. I was getting all excited. It just asks how much is in here, which is 13.5, right? What does the calculator give you? Did someone do it? 0.136. Is that what you said? Okay, 595 about. All right, let's keep going. The empirical rule is used to analyze normal distribution, but it's when you have things that aren't falling exactly on those lines, like the 16%, not exactly one standard deviation above or below, or 2 standard deviations above or below, they use the z-score. The z-score is basically the number of standard deviations that a given data value is from the mean. Okay? How many z-scores away from the mean? And you're going to get a decimal. They're not generally going to be whole number z-scores. So what you do is you take the score minus the mean divided by the standard deviation. This is also on the green sheet, yes? Anybody have the green sheet out? Does it say z-score somewhere on the green sheet? Okay. The z-score can be positive or negative because I thought I had one here. If it's above the mean, it's positive. If it's below the mean, it's negative. Does that make sense, guys? Because the mean is going to be here. All right. So this is how easy it is. There's a quiz question and a test question, or a quiz question and maybe even a question on the final that says, solve this. Okay, here's the formula. It's going to be given on the reference sheet. Find the z-score if you are talking about a score of 65 when the mean is 50 and the standard deviation is 10. How many z-scores, how many standard deviations is that? It's 1.5 and it's positive because it's 1.5 standard deviations above the mean. That's all that means. All you have to do is write 1.5, but I'm just trying to explain what it means, okay? This one says, what if you had a z-score of negative 0.4 when the mean was 40 and the standard deviation was 5? What was the score you had? So it's, you guys are algebra literate. Yes, you can work this backwards. This would be negative 2, is that right? If we add 40 over here, we get 38. So what does that mean? A score of 38 was negative 0.4. What does the negative 0.4 mean? Below. So it just means 38 was 0.4 standard deviations below the mean. Okay, I'm just trying to put that in words for you. All right, so that's nothing complicated. So this is the z-score business. It's the same percentages. Z-scores are really, in my opinion, kind of old school, okay? Because z-scores, they gave you this lovely little chart in your book, in the back of your textbook, back in a day when you didn't have a calculator that would change this. We have a calculator that will let us do this exactly. We just talked about this, okay? We're using this normal CDF. If you want to find the probability at exactly a particular score, so you don't have a upper and lower limits, then you use normal PDF. Okay, that's the probability at a specific place instead of the combined probability. All right, and this is what it will look like then. And you can, again, you can put a z-score in, but you don't have to. You can put a number in. It will default to 0 and 1. Why is it defaulting to the mean of 0 and the standard deviation of 1? Look, mean of 0, standard deviation of 1, yes? If you put a z-score in, that's the default. But you don't have to use a z-score. All right. Here's an example. It says the average number of phone calls received by a customer service rep during a 30-day month was 105 with a standard deviation of 12. Find the number of days with fewer than 110 phone calls. So we want to know from 0 to 110, basically. Okay, so let's just use what we're feeling pretty comfortable with. If you go here to normal CDF and you put in no phone calls up to 110 with a standard deviation of 105, I'm sorry, a mean of 105 and a standard deviation of 12. That's from the question in here. It says a mean of 105 and a standard deviation of 12. Then what do you get? 0.66? That's not what they have. Oh, that 0.42 is their z-score. They did a z-score. But they still, right here, 0.66, is that the same thing, roughly? Okay, they used a rounded z-score. So 0.66 times what, though? Says how many days? So we had to do 0.66 times 30 days, this question was. 30-day month. So they got around 20 days. All right, do you have this example on the back of worksheet 11? It says, on his last 20 airline trips, an employee had an average layover of 82 minutes with a standard deviation of 7.5. Find the number of layovers that were less than 75 minutes. We could use the z-score or we could not, okay? Let's just do one with the z-score. If you do the z-score, you would take the less than 75 as his cutoff, minus the mean, which was average, was 82 with a standard deviation of 7.5. Somebody type that in. I'm assuming we're getting negative 0.93. Okay? Now, if we want to know the probability that he has less than that z-score, you can, again, I don't ever do this because I just put the actual numbers in, but you can go down here and you could say nothing to, nope. What is z-score? What's the limit, guys? You'd have to do -4 z-scores to negative 0.93. Yeah, I'm thinking we should have just used 75 to 82 because this is just going to confuse somebody. Yep. What did I do wrong? Oh, I know what I did wrong. Duh. If you're using using z-scores, what's the mean? Yeah. The mean is 0 and the standard deviation is 1. Yes. Oh, what did I do now? This should have been. All right. Is that what they have? 17.6%? Okay. Times how many flights did he go on? 20? So about 3.5 or 4 of his flights had layover times that were less than 75 minutes. That stinks. He's getting a lot of layover time. All right, the way I would have done this question, because I don't want to use a z-score, what would I have typed in, guys? The lower, 0, the upper, what did you want to know? Less than 75? Where the mean was 82 and the standard deviation was 7.5, and then I get this and I multiply it by 20 and you get about 3.5. Okay, much easier, right? Okay, so let's try this one. At a restaurant, the average time between an order being placed and it being served is 12.5 minutes. What is that telling us? The mean is 12.5. The standard deviation is 1.2. Out of 100 selected customers, how many will be served within 14 minutes? So from what to what? What's the least amount of time it would take to get your food? In real life, 0, right? So if we want within 14 minutes, we want from 0 up to 14, where the mean is 12.5 and the standard deviation is 1.2. And then it said out of 100, so when we get an answer, we're going to multiply that by 100. .894 blah 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 times 100 is going to be 89.4, or roughly 89 meals served with under 14 minutes or within 14 minutes, right? Everybody okay? Now, some teachers would say you shouldn't use 0 here. You should use whatever 4 standard deviations or 3 standard deviations. Doesn't matter. The same answer. Did you have a question? No? Okay. How many of the 45 professors earn less than Mrs. Kwan? So what's going on here, guys? Read this one. This is what she earns, right? And this is the mean and the standard deviation. So how do you want to do this one? Yeah, I would just go from 0 to hers, which is 48,600. And then the mean and the standard deviation. Anybody get an answer? .17 something, and then this is actually the number of professors, so we got to multiply by 45 professors. About 7.76, or about 8 professors earn less than her. Everybody okay? So try this one. How many days was the temperature greater than 51 or 50 degrees? Okay, how many days? Well, we need to know what then. How many days in October? It's everybody's favorite 31-day month, right? Because Halloween. Did I say 32? Oh. Out of 31 days. Okay, so this is the mean, this is the standard deviation. We want greater than 50 degrees. Yep. Yep. In my book, yes, we can just do this and it will be just fine. Times 31 days. What did we get? How many days? Yeah, sometimes in October there can be way above 50, but yes, it could also snow in October in Illinois. You just never know. All right. The average age of swimmers on a master swim team is normally distributed with a mean of, oh my goodness, that was horrible, 56 and a standard deviation of 4. I'm just going to sketch this one. 60, 64. Hey. What did we just say? All right. Between 53 and 59. If we were doing this according to the empirical rule, would this, it wouldn't work, right? It's not exactly, we'd have to do a z-score thing or something. Because it should be, did I do something wrong? I'm supposed to be going down by 4s, right? Yeah, because the standard deviation is 4, okay? That's all right. To 59. So it should be, our percentage should be less than what? Less, wait a minute. Whoa. 53 and 59. If it was 52 to 60, what percent would that be? This would be 68% according, okay, so it should be less because we're a little bit inside of both. So go ahead and do it. 53 to 59 with 56 being the mean and 4 being the standard deviation. And what do you get? Okay, is that a probability right there? 0.547? That's a probability, that's all it's asking. Okay, less than 53. If I looked up here, guys, at my graph, less than 53 should be what? If this is 34% and this is 50%, should be about 16 down here. Okay, what are we going to type in if we're doing it this way? We could do 0 to 53. You do? Oh, I know why it wasn't. Because it was 52. I was going from 52 would be 16%, but it actually goes up to 53. So it's including this chunk in here. Somebody else get that number? Okay. We got to keep going because the other thing they're going to ask us to do is to work backwards. It says you found the area under the normal curve corresponds to a z-score. You can also find a z-score that corresponds to a specific area. So if you know you want the middle 20%, you can work backwards on the calculator. It's called inverse of the normal curve. All right. So here's an example. If you want the middle 50%, you could say, I want the inverse norm of 0.25, because that's 25% this way, and it would give you negative 0.67. And if you said I want 25% this way, it'll give you positive 0.67. These are z-scores. It's telling you the z-scores would be between here and here to find the middle 50% instead of the middle 68%, which would be from -1 to 1 z-score. All right. So it says the outside 20%. Well, if this is 50%, how do we get down here? Means there's a 10% down here and a 10% up here, right? So you use inverse norm of 0.10 and inverse norm of 0.9, and it says the z-score is between negative 1.28 and positive 1.28. Below that and above that. All right. Yep. When you do inverse norm, okay. You would just put the z-score in here and leave this. Okay. So the middle 25%, what's the percentage you're looking for? Okay. This is 50. If you go 12.5 below that, what's 50 minus 12.5, guys? 37.5. Did I do that right? If you go 12.5 this way above 50, you'd be at, okay. So if we put in 0.375 here, I think that would tell us a z-score of negative 0.32. And we should get the positive 1 if we put in the other. 0.625 is positive 0.318. So the middle 25% would fall in between these two z-scores. All right, let's talk about how we're going to do this. All right, well, first we're going to do it with z-scores, apparently. Middle 60%, guys. So if you're at 50, how far are you going to go either way? No, you want the whole 60% to be here. So you're going to go 30 each way from 50. The middle 50%, I need 30 on either side of that. Does that make sense? To find the middle 60%. Okay. So this is 20, and 30 this way would be 80. So now you're going to do inverse norm of this, leaving the mean at 1 and the standard at 0 and standard deviation of 1. It should be 0 and 1, I think. Gotta look at the screen again here. Inverse norm, which is choice 3. The area, we want to find out what it's called at 0.2, and you're going to leave this at 0 and 1. And what should the other one be if we did it right? So the z-score is somewhere in between here. I shouldn't have put those parentheses, but. All right, this is not on the quiz, just so you know. Okay. Outside 30%. So that just means, guys, 15% down here and 15% up here. Would that be the outside 30%? Does that make sense? Okay, so can you just do 0.15, 0, and 1 for me? Negative what? Negative what? Oh, it's a z-score. I forgot. Okay, so a z-score less than that or a z-score greater than 1.03 would be the boundaries for that area. All right. So we're going to try to find some things. This is part D is where we need this inverse norm. Right here it just says the price of rooms at hotels around an airport are normally distributed with a mean of 120 and a standard deviation of 20. What's the probability that the room costs more than 150? Well, it should be something less than 16%, I would say 50s. So we're going to just put in normal CDF, and we're going to put in what? Greater than 150. So we'll have 150 to, yeah, some big 999 number, and then 120 and 20. And it just wants a probability. So we just need a decimal. Someone else getting that number? Okay. So about 6.7%. All right, between 110 and 130, what are we going to put in this time? Just 110, 130 with a mean of 120 and 20. What is it? 0.383, like that? So about 38% of the time we should be able to find a hotel room between those costs. Okay, between 90 and 100. Now we're getting down here into this little area right in here. Not going to be so much, I think. About 9% of the time the hotel room will cost that. All right, if only the most expensive 10% of the rooms are available, what is the least you would pay for a room? Okay, so we want to know this 10% that's out here. We need to know the z-score for that. Okay, so we're going to do inverse norm. What's that percentile if it's the top 10%, guys? 90. So underneath is 0.9 and leave this 1 and 0. Is it 0 and 1? Yeah, it is. Thanks. So totally backwards. 1.28. Okay, that's our z-score. Now, what's the formula for the z-score say? Minus mean divided by standard deviation. What are we trying to convert it to? Yeah, we need this x value. So we have 1.28 equals x minus 120 over 20. So 1.28 times 20 is 25.6. We add the 120, we get I'm out of room. 145.6. So what is the least you'll expect to pay for a room? Yes. Most expensive 10. So if we put in 0.9, 1, the mean of 120 and the standard deviation of 20, and then it should give us the same answer. Yes, I think you're right. Does it give you the same 145.6-ish number? Yes, it is. Okay. Better idea. All right, so that is, what is the, if you want only the most, what is the least you expect to, so you're going to stay in the nice hotel rooms. You're going to pay at least $146 probably. All right. Students who score in the bottom 5%. So that's 0.05. With a mean of 122.6 and a standard deviation of 8. Guys, 18. Type this in real fast, guys. Somebody doing this for me? We got one more question that deals with SAT. 92? Okay, so what is the greatest score? If you got a 93, a score of 93 on this physical fitness test, you're still in the bottom 5%. So you would have to take this supplemental program, okay? For the out of shape people like me. Oh, I had 2 more questions. This is the one I wanted to get to. If you got a 65 on a test with a mean of 50 and a standard deviation of 10, and on another test you got a 30 with a mean of 25 and a standard deviation of 5, which did you do better on? This one you were more z-scores above the mean, right? Yes, you're further above the mean on the first test, the biology test. All right, guys, the worksheet you have to do on this is worksheet 15, okay? Work day tomorrow, then I'm back for review day Wednesday, quiz on Thursday.